Hi, welcome back. Today we're going to take a look at how we take the derivative of a composite function. We already know power rule, product rule, and the quotient rule. Of course, the product is when we are multiplying, and the quotient rule is when we are dividing. A composite function comes from Algebra 1. It's where we stick one function inside of another. For example, if I said let's let f of x equal the square root of x, and if I say g of x equals the sine of x, I can write the composite f of g of x as the square root of sine of x. So in this one, we're going to have an outside function that we just call f. And we're going to have an inside function which we call g of x. We can another way to think about a composite function is like one of those Russian nesting dolls. We have one doll stacked into another. Here I have like an example. I can stack each one of these inside this big doll. This little one can be stacked in here, this one can be stacked in here, and so on and so forth. We can use this example to determine how to take the derivative of a composite function. And here's what we have. We actually have one example here. We have an outside function. And that's what this one. The outer function is a cubic. This is like the biggest doll in our nesting. So this would be like my outside function. Inside of it, I have another function, this 3x squared plus 2x. There is my inside. Well, and that's all of these. Like here's my outside one, here's an inside. Now notice we do have more dolls because we can't have more insides. We'll talk about those later on. So in order to take the derivative of this, what we're going to do is we're going to look at the derivative of the outer function. Well, if my outer function's derivative, if my outer function's derivative, I can just take that. That becomes 3, hold on here, something squared. That's just my power rule. But we're not changing the inside. Just like the nesting doll, if I'm only looking at the outside doll here, there's still other dolls inside of that doll. So this function, 3x squared, is still inside my bigger doll, or my outside function. So this 3x squared plus 2x is still inside my outside function when I take the derivative. And then our next step to do is take the derivative of the inside function. Well, the derivative of my inside function is going to be 6x plus 2. That's my inside function right there. So when we take that derivative, now we have the derivative of the outside and we have the derivative of the inside. And all we're going to do is we're going to multiply them together. So therefore we can say, our derivative, f prime of x, would be the outside derivative we just took, 3 times x squared plus 2x squared, times the derivative of our inside function. And that is how we take that derivative. So here's our rule for us today. Here's our rule. Chain rule, or how I love to take the derivative of composite functions. If we have a composite function, f of x and g of x, where we have an outside function, we have an inside function, our derivative is just the following. We're going to take the derivative of the outside. But remember, just like the nesting doll, we're going to leave the inside alone. So we're going to take the derivative of the outside, and then we're going to multiply that by the derivative of the inside. So we can say this is just d out, the derivative of the outside, times, that is not how you spell inside, there we go, times the derivative of the inside, d out, d in. Very easy rule. Most students really like this rule. It's pretty easy to work with. Matter of fact, let's take a look at an example. Number 1, we're asked to find the derivatives. Do not leave negative exponents or complex fractions. This is going to hurt us more like tomorrow. So for question number 1, if we want to take this derivative here, I have an outside function. That is this cubic function. So my rule says, take the derivative of the outside, and that's going to give me 3x cubed plus 1. Now, I'm going to do something a little bit different than I'm used to, but we're only going to do it for this one example. And then we're going to multiply that by the derivative of the inside. So I'm going to write this, the derivative of my inside, which is just x cubed plus 1. That's really what we're doing. And you should put a dx there. We're never going to do this again because it just takes too much time. Because now we got to simplify it. This becomes 3x cubed plus 1 squared times, and the derivative of the inside here is just 3x squared. And you leave it alone. You can simplify this if you like. For example, you can make this 9x squared on the outside there. And there's our derivative. We're never going to do this again, so I just want to show you that. So it's the derivative of the outside times the derivative of the in. All right, so for example number 2, here we have this 3x cubed minus 2x to the 7th. When we take the derivative, we're going to get, f prime of x is, my outside derivative just becomes 7 times 3x cubed minus 2x. Remember, leave the inside alone, but don't forget to do your power rule there, 6. Times, and now I want the inside derivative. So I now need to take the derivative here. And this is what we call the chain rule. Because now I'm going to take the derivative of this inside, which becomes 9x squared minus 2. Now notice, I put this in parentheses. Parentheses are very important for today. And there's our answer. There's the derivative. All right. So let's try a slightly harder one. Rationals. First, we talked about this beforehand. We are going to write this as x squared minus 1 to the 1/3. When we take the derivative, we are going to bring down our power, our outside function here, our outside, and that's going to become 1/3 x squared minus 1. Leave that inside alone. When you take the derivative of the outside, remember, leave the inside alone here. We're not working with the inside. It's that nesting doll. There's more dolls on the inside, outside. When I subtract 1, I get negative 2/3, which if you're good, you know that's going to cause an issue for us later on. But now I have to look at the derivative of the inside. So now I look at this inside, and that's going to give me 2x. The derivative of x squared plus 1 minus 1 is 2x. So there's my derivative. But remember, we don't like negative exponents, so we are going to have to simplify this one. And when I do that, I just think, what goes on top, what goes on bottom? The 3, it's going to go on bottom. This x squared minus 1 to the 2/3, well, because that's a negative exponent, I know this has to go on bottom. And now the 2x. Well, the 2x is, there's no negative, so it just stays on top. And there is our final derivative here. Yeah, kind of ran out of room there. And there's our derivative. Pretty easy to do. All right. Let's get tricky with it. Number 4. Oh, number 7. Don't look at that one yet. All right, number 4. When we're taking the derivative of a trig, just remember, if I'm looking at the outside, so I've got f prime of x, if I'm looking at the outermost function, these are really obvious. What is the derivative of tangent? Well, we should know that that's cosecant squared. So I'm going to write this. That is embarrassing. It is secant squared. Excuse me, the derivative of tangent is secant squared. Maybe I should watch my videos. Secant squared. Now remember, the inside, we're leaving it alone now. We haven't done anything with the inside. Remember, this right here is just the derivative of my outside function. But now we're going to apply the chain. This is our chain rule part. The derivative of my inside is just 3. And there's my answer. Very easy to do. So try one with cosine here, and then we'll talk about number 6. So if you need to pause it, go ahead and pause it and try it. I'm going to go and do it right now. When we take the derivative, we're going to get f prime of x. Well, what is our outside function? It is cosine. So when we take the derivative of cosine, we get negative sine. Remember, leave the inside alone for now, x squared minus 1. But now we're going to do the derivative of the inside. Now we're going to apply our chain rule. And what's the derivative of x squared minus 1? Dos equis. Stay nerdy, my friends. And there we go. And there's your answer. Pretty easy to do. Now, number 6, does look kind of nasty right here. But let me just share something with you. This is the secant of x cubed. Now, when we do chain rule, notice everything is inside. We literally see inside something. We're inside some sort of parentheses. I'm taking the derivative of the parentheses. I'm taking the derivative, multiplying by the derivative of what's in the parentheses. I'm taking the derivative of what's in the parentheses. I'm taking the derivative of what's in the parentheses. But for number 6, notice there are no parentheses. It's just secant of x cubed. So, well, what can I do? Well, I can make this a parenthesis. That's really secant of x cubed. So if they don't give you parentheses and you have a hard time, just put the parentheses there. Now, when we take the derivative, well, what's the derivative of secant? Well, that is the secant of x cubed times the tangent of x cubed. Remember, the derivative of secant, if you forgot, is secant x tangent of x. Now, be careful, our x here is x cubed, so we got to make sure we put the x cubes back in, okay? Be careful with that. And then our last step, now we do our chain. Now we got to do the inside. Well, what's the derivative of x cubed? 3x squared. And there is our derivative. Now, note, please note, I'm not multiplying by both of these by 3x squared and then another 3x squared. I only have to do it once because there is only one inside in the original function, and that's the x cubed. The derivative of that inside is 3x squared right there. All right, so let's take a look at number 7. Now, number 7 is where it gets a little bit wonky for us. It's this cosine cubed of x. Man, this one's kind of a nasty one. So what I tend to suggest to students at this point, let me zoom in here. I want to make sure we can all take a look at this real quick. Okay? What I suggest for students on number 7 is this. I don't like this because what's on the outside here? I don't know. It looks like cosine might be on the outside, but it's fake. This looks pretty, but it's not very useful for us. So we are going to rewrite this every time. I'm going to write this as cosine of x cubed, because that's really what's going on. This is saying take the cosine of x and cube it. This looks pretty, but it's not very useful for us in terms of mathematics. So this is how we're going to write it. And now, if you notice, what is my outside function? It's going to be the cubic. My inside function, that's just cosine. So when I take the derivative, f prime of x, my outside derivative, we're going to get this 3 cosine of x squared. Remember, we left the inside alone, right? That's just the derivative of the outside. And now I'm going to multiply that by the derivative of the inside. Use my chain rule. What's the derivative of cosine? Just negative sine of x. And there's your derivative. There we go. There's your derivative. That's probably one of the hardest ones I will ever give you in a million years. That's the hard one. If you can do this one, man, there's really not much I can't throw at you that you won't be able to do. Except for number 8. Here we go. Cosecant squared. Cosecant's a nasty little bugger. So, I'm going to stop the video here, but go on to my next video, and we'll take a look at this one and a few more examples. See you then.